All right, so let's tie those things together. So what we're going to be doing is we're going to be factoring polynomials using synthetic division. You could use long division, but nobody's going to. And the first step is to find a zero. So you're going to use that rational zeros theorem to find a potential zero. And then you're going to use synthetic division to find the quotient. And then you're going to repeat until you're left with a quadratic that you can factor. So if you look at this one, right, we're starting with a cubic function. We're going to take this down to a linear times a quadratic, and then in our last step we are going to have three linear functions multiplying together. Now I could go through and I could put these x's in because I knew that the coefficient on the x cubed term is a 1, so I know that in the end it's going to be x times x squared gives me x cubed, or x times x times x gives me x cubed. And then what we're going to do is try to figure out the rest. So step number 1, here's how you're going to do step number 1. Now step number 1 says use the rational zeros theorem and then find the zero with either remainder theorem or synthetic division. What that means is you're going to look for a number that when it plugs into this equation gives you a remainder of 0. Now you can do that using the remainder theorem, which is the plugging in, or you could just jump straight to synthetic division if you're loving synthetic division, or you kind of always make mistakes using the remainder theorem. But the first thing we're going to do is list our potential zeros. So the potential zeros for this function are all the factors of 6. So plus or minus 1, 2, 3, or 6. And then you would always divide that by this guy, but since it's a 1, none of them are going to change. And to be honest, I always start with these. Like I'm always going to try 1, 2, 3, and 6, even if there is a coefficient here, because I don't want to start doing fractions if I don't have to. Now that I have my potential zeros, now I have to figure out which of these is going to make my remainder 0. Like I said, you can jump straight into synthetic division if you want, but usually what people do is the remainder theorem. So we're going to start by plugging in x is 1. And honestly, this is the most painful part of the entire process, is trying to find a potential 0. So we've got 1 cubed plus 2 times 1 squared minus 5 times 1 minus 6. I can already tell you this is not going to equal 0. I've got minus 11. So I'm looking at that going, ooh, okay, maybe I should have tried -1, because if I put in a -1, that'll turn this positive. So now we've got -1 cubed plus 2 times -1 squared minus 5 times -1 minus 6. Now does that equal 0? Well, let's check. -1 cubed is -1, and then we've got plus 2, and then we've got plus 5, and then we've got minus 6. So that did equal 0. So I have found one of the zeros of this polynomial function. So then I get to move on to step 2. Step 2 is to use synthetic division to find the quotient. So what you're going to do is you're going to take that -1 and you're going to write it in the box. Then you're going to draw your line, and you're going to take your coefficients off of this cubic function. So we've got a 1, a 2, a -5, and a -6. There's no missing terms. And then we get to do the process. So you're going to bring down, and then you're going to multiply. -1 times 1 is -1. And then you're going to add. 2 plus -1 is 1. Then we multiply. -1 times 1 is -1, and then we add, and we get -6. And then we multiply. -1 times -6 is +6, and then I add, and if I've done this right, I have to get a remainder of 0, right? They have to match. And what this means is that I have now factored this cubic function into a linear factor. So if my 0 is -1, my linear factor is x plus 1. And then I have my quotient, which is the answer of the division question. So these are my coefficients. So I did a cubic divided by a linear, so it's going to go x squared x constant, or you'll go constant x squared, I don't care. But you get x squared plus x minus 6. And that's the process. And the only thing that we can do to make this harder is start with like a quartic or a quintic function, so that you have to do this process a couple times. But we don't have to repeat, because I've got myself down to a quadratic which I can factor. So this x plus 1 remains a factor. And then I'm going to say, what are two numbers that multiply to give me -6 and add to give me 1? That's going to be plus 3 and -2. Now, if there's anyone who's always hated, factoring trinomials, these do always come down to trinomials. Don't forget you have other options. You could use the quadratic formula. once you're down to a quadratic, and then you'd know your zeros and you can translate them back into linear factors. What else could you do? You could, I mean, you could complete the square, but no one's going to do that. So really, I'd say quadratic formula or just get used to factoring, and they never end up as numbers that are too big. All right, that is it. So let's move on to the next question. So for this one, again, we have another cubic function. I will have one coming up in the sketching section where it is quartic. So yeah. I just had to go and check your assigned questions. So I was like, yeah, you might want to watch the next video before you do number 45 in the recommended practice questions, just because it is a quartic function and it is just one more step. So, just keep that in mind. Maybe go after this video and do numbers 39 and 41 in the homework, and then hold off on 45 until you watch the first example of the sketching polynomials section. But let's just do this again. So first off, we're going to figure out what is my zero of this function. So the thing that when I plug it in makes the equation equal to 0. So again, you're going to use your factors of your constant. So we would have plus or minus 1, 2, 3, 4, 6, 8, 12, and 24. Blah. I wish there was a shortcut to this. I really do. Okay, so I'm not going to try 1 because there's this massive negative 24 that I'm going to need to balance. So I'm going to move on to the 2's. They don't usually make you go too far with this. I will say that when I was writing the test, I was like, you know what, I'm just going to kickstart. Here's your 0 to start with, just because that's the thing that can kind of slow you down. But we're going to try 2. Now the question is, should we try positive 2 or negative 2? When I look at this, we're trying to balance a negative 24. So I'm going to try f at 2 first. So we're going to have 2 cubed plus 5 times 2 squared minus 2 times 2 minus 24. And then we're going to plug that in. So I've got 8 plus 5 times 4 minus 4 minus 24. Ha ha ha, look at that. We got so lucky. So step number 1, we found our 0. So the next thing we're going to do is we're going to set up our synthetic division. So this is step 2. And using synthetic division, we're going to put that number in the box. And then we are going to take off our coefficients. So we have a 1, we have a 5, we have a negative 2, and we have a negative 24. And then we're going to bring down, and we're going to multiply. And then we're going to add. And then we're going to multiply, and then we're going to add. I never know if I should actually say what I'm multiplying. Then I've got 2 times 12 is 24, and then I'm going to add, which gives me a remainder of 0, which is what I'm expecting. But now I know my quotient. Now, sometimes when I'm setting up these questions, I'll do sort of a thing over on the side just to remind myself. So my first step is going to be taking this from a cubic function to a linear times a quadratic, and then the next job will be taking it down to 3 linear factors. So you can actually just start with that, and it kind of reminds you why you're doing this. So this is going to be my linear factor. So remember, if your 0 is x equals 2, if you bring that to the other side, you end up with x minus 2 as your factor. And then we're going to take this as our next part. So we divided a cubic by a linear. So this first one's going to be an x squared, or you can start here with constant and then x squared. And then we're going to write that as our quotient. So we've got x squared plus 7x plus 12. And then again, we're looking for 2 numbers that multiply to give me 12 and add to give me 7. So it's going to be x plus 4 and x plus 3. So we've done it. So we've factored using synthetic division. And you'll know you're done when you're down to a product of linear factors.